Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. So today we are going to look at Calculus 2 and our main topic is how to integrate problems where we have powers of sines and cosines. In particular, we are going to be integrating sine ax raised to n, where n is a natural number different from 1, and cos of bx and everything raised to n, and a natural number different from 1. A and b are real numbers. So when we talk of powers of sines and cosines, remember you can have odd power and even or even powers. So let's start with the first one, where we have, I can call it case 1. It's a case where you have odd powers. Odd powers. Okay, let's start with the even powers. Then we look at the odd powers later. I want us to start with even powers of sines and cosines. I'll write here even powers. Or simply the case where n is an even number. N is an even number. An even number is a number that is divisible by 2. So what are we supposed to do in this case? We are going to use these trigonometric identities. I'm going to list them down. Why are we using such trigonometric identities? Because we need to express the integrand in terms of cosines or sines of multiples of the angle x. So what you're going to do here is to use this identity that cosine squared theta minus sine squared theta, this is the same as cos 2 theta. Another identity is cos squared theta plus sine squared theta is equals to 1. Cos squared theta plus sine squared theta is equals to 1. So if I want cosine squared theta, this is what I'll do. If I add the two equations, I am going to get an identity for cosine squared theta. So let me add them. If I add, I'm going to get this. I can write it here. Let me delete this. So when you add, you're going to get 2 cosine squared theta is equals to 1 plus cos 2 theta. 1 plus cos 2 theta. I'm going to write it. So I want to make cos theta squared the subject. So from here, it is clear that cosine squared theta is the same as 1 over 2 into 1 plus cos 2 theta. So this is an identity that we'll make use of when integrating cosine squared theta. So let me bracket it. Again, what if you want sine squared theta? What are we supposed to do? So now, instead of adding, let me now subtract. So the 2, instead of adding, I now want to subtract. So what will I get if I subtract? I am going to get this. So it's like I'm taking equation 2 minus equation 1. So we'll have twice sine squared theta is the same as 1 minus cos 2 theta. So I can divide by 2 on both sides to get sine squared theta as the subject of the formula. So you can just say therefore sine squared theta, this is the same as 1 over 2 times 1 minus cos 2 theta. It's another identity that we are going to use when you are integrating sine squared theta. Remember, instead of theta, you can use x if your integrand depends on x. So let's look at some examples. We'll look at 4 examples and then we'll go to case 2. So we can write examples. Let me write examples. You are asked to evaluate the following. Evaluate the following. In part A, we want to integrate sine of 4x raised to 2. The integral of sine raised to 2 of 4x dx. So how else do we write sine squared of 4x? Remember, look at the identity number 2. Let me take them. You see this one is the one we are going to use. So in this case, our theta is equals to 4x. So we can say this is the same as the integral of 1 over 2 times 1 minus cos 2 theta. This is our theta. Our theta is 4x. So twice of 4x, that is 8x dx. And so 1 over 2 is a constant which can be factored out. So it's 1 over 2 times the integral of 1 dx minus 1 over 2 times the integral of cosine of 8x dx. So that if I integrate, I'm going to get 1 over 2x. What did you differentiate to get cosine? It is sine. When you differentiate sine, you get cosine. So this negative 1 over 2 times sine 8x over 8 plus a constant c of integration. If I simplify this, I'm going to get 1 over 2x minus 1 over 16 times sine 8x, and this is added to c. C is a constant of integration. Another one, let's see how to integrate cosine squared of maybe 5x, whichever angle. So we can write part B, the integral of cosine squared of 5x dx. So in this case, our theta is 5x, this theta. So how do we integrate this? It is the same as the integral of 1 over 2 into 1 plus cos 2 theta. 2 theta, theta is 5x, so 2 theta will be 10x. 10x dx. And so this you can also write as 1 over 2, the integral of 1 dx, plus 1 over 2, the integral of cosine of 10x dx, which when you integrate you get 1 over 2x plus 1 over 2. When you integrate cosine, you get sine. So that is sine 10x, everything over 10 plus a constant c. And so this can also be written as 1 over 2x plus 1 over 20 sine of 10x plus c. What of if the power is not 2 but it is 4? The power different from 2. Let's write part C. Part C, you want to integrate cosine raised to 4. Cosine raised to 4 of 2x dx. I need to express this as sines and cosines of multiples of x before I integrate. So express cosine raised to 4 of 2x in terms of cosine or sines of multiples of x. So let's start by expressing that. Take note that cosine raised to 4 of 2x is the same as cosine squared of 2x, and this is squared. And we know cosine squared of 2x is the same as 1 over 2 into 1 plus cos 4x, and this is now squared. Cosine squared of 2x is the same as half in bracket 1 plus cosine of 4x. Half squared, that is 1 over 4. So we have here 1 plus cos 4x, and the whole of this is squared. So when we square this, what are we going to get? It will be 1 over 4. Remember a plus b squared. A plus b squared is the same as a squared sorry, plus 2ab plus b squared. So when we expand that, we are going to get 1 over 4 outside. 1 squared is 1 plus 2 cosine of 4x plus cosine squared of 4x. So now you need to know what is cosine squared of 4x. Cosine squared of 4x, so this will be 1 over 4, 1 plus 2 cos 4x plus, let's square cosine of 4x. That will give us 1 over 2 into 1 plus cosine of 8x. So cosine squared of 4x gives us that, of which now if I open the bracket, it will now be, let me factor out 1 over 2. So simply open the bracket, 1 over 4 plus 1 over 2 cos 4x plus 1 over 8 plus another, of course it's 1 over 8 in bracket. Let me wrap this. 1 over 8 in bracket, 1 plus cos 8x. And then you can now open it fully so that you see I'll be having 1 over 8 plus 1 over 4. So instead of writing this one, I could have written, because now you see what is happening. 1 over 8 times the entire bracket will give us 1 over 8. Then we have here plus 1 over 8 cos 8x. So add this 1 over 4, this one, add it to this. That will give us 3 over 8. So that is equals to 3 over 8 plus 1 over 2 cosine of 4x plus 1 over 8 cosine of 8x. So this is what we need to integrate now. Let's go back to our integral. So now this integral can now be written as the integral of 3 over 8 plus 1 over 2 cos 4x plus 1 over 8 cosine of 8x dx, which when you integrate term by term, you are going to get 3 over 8x plus 1 over 2 times sine 4x over 4, then plus 1 over 8 times another sine of 8x over 8 plus a constant c. And if I simplify this further, I am going to get, let me use a different color. I'm going to get 3 over 8x plus 1 over 8 sine 4x plus 1 over 64 sine 8x plus c. So that's how to integrate cosine raised to 4 of x. What about when you have sine raised to 4, sine raised to 6, cosine raised to 6 of any given angle? You do the same as we have done this one. So let's look at another case. That is case 2, where we have odd powers. Case 2. That is when we have odd powers, or simply where n is an odd number. So I'll write that odd powers. Odd powers. What I mean here is where n is an odd number. N is an odd number. So what are we supposed to do in this case? We are going to use another trigonometric identity. We are going to use this identity and write it. You know that cosine squared theta plus sine squared theta is the same as 1. So we use that identity. Use this after breaking the powers into a product of even and odd powers of sines and or cosine. I'll tell you how to do it in an example. We can write example. Let's say we want to evaluate the following. We look at just 2 examples to illustrate this concept. So in part A, we want to integrate sine raised to 3 of 2x, the integral of sine raised to 3 of 2x dx. So the first thing here, you break down this sine cubed. Remember, sine cubed, you take note that sine raised to 3 of 2x can be written as sine of 2x times sine squared of 2x. But what is sine squared of 2x? Now use this identity. Sine squared theta is the same as 1 minus cos squared theta. So this is the same as 1 minus cosine squared of 2x. And so when I multiply, I am going to get this to be equal to, remember this is in bracket, so sine 2x times everything here will give us sine 2x minus sine 2x times cosine squared of 2x. So that's what we need to integrate. So our integral will now look like this. It is now the integral of sine 2x minus sine 2x cosine squared of 2x. We are integrating this with respect to x. So we can split this integral into two parts because of the linearity property of integrals. So this, the integral of sine 2x, let me write this in a proper manner, sine 2x dx minus the integral of sine 2x times cosine squared of 2x dx. Now, what do you get when you integrate sine 2x? So that will be equal to, remember when you differentiate cosine, you get negative sign. So for you to get positive sign, you must differentiate negative of cosine. So that our result of integrating sine 2x should be negative cosine of 2x divided by 2. The other one, how do we integrate the other integral? Here you have to use u substitution. Here you are going to say, let u be equal to cos 2x, so that du dx, when you differentiate cos, you get negative sine 2x times 2, negative 2 sine 2x, let me write that. When you differentiate cos 2x, you get negative 2 sine 2x dx. So it means now we are integrating, remember here there's a minus, so we're now integrating sine 2x times u squared, make dx the subject. Dx here is the same as du over negative 2 sine 2x. So you see sine 2x will cancel with this other sine 2x, so it's like you have negative 1 over 2, the integral of u squared du, which will give you negative 1 over 2. Use a power rule, add 1 to the power, so that is u raised to 1, u raised to 3, 2 plus 1 is 3, u raised to 3 over 3. because there's a constant c of integration. So this will give you negative 1 over 6 u cubed plus c. And our u is cos 2x. So this can now be written as, you can now write this as negative 1 over 6 cosine cubed of 2x plus c. So that's what I write here. I come back to our answer. So this, we have found negative 1 over 6 cosine cubed of 2x plus c. A negative followed by a negative is positive, so our final answer here will be negative 1 over 2 times cosine of 2x plus 1 over 6 times cosine cubed of 2x plus a constant c. So that is very easy. And lastly, let's look at if we have cosine raised to 5 of 3x. How are we supposed to go about this? So I'll give you another, we write that as part B. Part B, you want to integrate cosine raised to 5 of 3x dx. So again, you have to break down this. Cosine raised to 5 is the same as a product of cos 3x times cosine raised to 4 of 3x. So this is the same as, we can do it somewhere. Take note that cosine raised to 5 of 3x can be written as cosine of x, of 3x I mean, times cosine raised to 4 of 3x. But what is cosine raised to 4 of 3x? That is cosine raised to 2 of 3x, then you square it. So this can be written as cos 3x times cos squared 3x, and that is squared. And we know cos squared 3x, so this is equals to cos 3x in bracket, cos squared 3x the same as 1 over 2 into 1 plus cosine of 6x. Remember, this is squared. So when you square 1 over 2, you get 1 over 4. So this will now give you 1 over 4 cos 3x times 1 plus cos 6x. And this is squared. So let us square that. We are supposed to get now 1 over 4 times cosine 3x. When you square this one, you get 1 plus 2 cosine of 6x plus cosine squared of 6x. That one. And so you can expand this one, but I wanted to show you the easiest way. Instead of having to replace, instead of having to use this substitution here, 1 over 2 into 1 plus cos 6x, I want to use the other identity that cos squared theta plus sine squared theta is equals to 1. So let me just, because we want to simplify this, we want to make our work easier. Of course, what you are doing will also give you the answer, but it's a long process. Let us make things as simple as possible. So I'm going to rub what I'd written initially so that I'm going to replace, instead of cosine squared of 3x, remember this is the same as 1 minus sine squared of 3x. That's what I'm going to write, 1 minus sine squared of 3x. And that's supposed to be squared. So that if I square the whole of that one, I'm going to get this. It is the same as cosine of 3x. Remember, a minus b squared is the same as a squared minus 2ab plus b squared. So this will give us 1 minus 2 sine squared of 3x, then now plus sine raised to 4 of 3x. So that's what we have. And then now open the bracket completely. When you open the bracket, you're going to get this. It is equals to cosine of 3x minus 2 cosine of 3x times sine squared of 3x, then plus cosine of 3x times sine raised to 4 of 3x. So it is now easy to integrate this. Integrate, let me show you how to go about it. Now we go back to our integral. What will it give us? It should now be the integral of cosine of 3x with respect to x minus 2 times the integral of cosine 3x times sine squared 3x dx plus the integral of cosine 3x times sine raised to 4 of 3x dx. So let's integrate the first term. The first integral, ask yourself, what did you differentiate to get cosine? You differentiated sine to get cosine. So this should now be equal to sine of 3x everything you divide by 3. How do we integrate this? Use u substitution. Here you let u be equal to sine 3x. Let u be equal to sine 3x. So we need to find du dx. So when I differentiate that, I'm going to get du to be equal to 3 cos 3x dx. So that integral will now, remember it is minus 2 times that integral, which is now the same as the integral of, look at cos 3x dx, that is du, so there's 3 somewhere. So you make dx the subject, so this will give us cos 3x times u squared. Instead of dx, we'll write du over 3 cos 3x. And you realize that cos 3x will cancel with this other one, so we'll have u squared over 3. What about this other one? Here we now let u to be sine 3x the same. so that we make the same substitution even here. So in this case, we expect to get plus the integral of cosine 3x times u raised to 4. Instead of dx, that is du over 3 cos 3x. Again here, cos 3x will cancel with cos 3x. So what do we have now? When we simplify, the first one is sine 3x over 3. Let me write that, sine 3x over 3. Here we'll have minus 2 over 3. Remember 3 in the denominator, times the integral of u squared du. And the other one, I can see this 1 over 3 integral of u raised to 4 du. And so this will give us sine 3x over 3 minus, remember, add 1 to the power using power rule. So this will give us 2 over 3 u cubed divided by 3 plus the other one is 1 over 3. So this will, when you add the power 1 to the power, you get u raised to 5, then divide by 5 plus a constant c. And finally, you need to replace u. Our u was sine 3x. So we replace it. Where there is u, you're going to put sine 3x. To get this, you want to get 1 over 3 sine 3x minus 2 over 9. So this will now be sine cubed of 3x, that is our u. So it is u cubed, then plus 1 over 15 sine raised to 5 of 3x plus a constant c. So look at how we have rewritten our integrand. And so you can try the other form that we tried but we didn't finish. Something you need to take note of is that when you have integrals involving powers of tan and sec theta, then what you use is the trigonometric identity 1 plus tan squared theta is equals to sec squared theta. Also, when you have the integrals involving powers of cot theta and cosec theta, then use the identity 1 plus cot squared theta is equals to cosec squared theta. Having talked of the powers of sines and cosines, thank you all for watching. When we meet next, we look at other integrals where maybe we have powers n is equals to 6 going onwards, or 7 onwards, even powers and odd powers greater than 4 and 5. So don't forget to subscribe to my channel. Also remember to share, comment, and like all the videos in my channel. Bye bye.